Welcome to the Real Python Podcast. This is episode 261. When considering an object-oriented programming problem, should you prefer inheritance or composition? Why wouldn't it just be simpler to use functions? Christopher Trudeau is back on the show this week, bringing another batch of PyCoder's weekly articles and projects. Christopher shares an article about structuring code using inheritance, composition, or only functions. We discuss how the piece is a good exploration of the trade-offs of each solution. Unlike the tutorials beginners typically encounter while learning the fundamentals, the piece goes much deeper into the why of object-oriented programming. We also share several other articles and projects from the Python community, including a news roundup, processing audio in Python, why you shouldn't call Dunder methods, smuggling arbitrary data through an emoji, an html-to-markdown converter, and a library to convert Python requests into curl commands. Hey there, I've got a quick request. We've created our first Real Python Podcast listener survey. We're trying to learn more about you, our audience, and what you're interested in us covering on the show. It's a quick survey, less than 5 minutes. You can click the link right in the show notes on your podcast player, or visit realpython.com/podcast, and the link will be in the show notes for this episode. Thanks. All right, let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hey, Christopher, welcome back.
Hey there.
All right, so we got not as much news as last time, but you were able to cobble together some additional items here at the last minute. So got a few extra things, and we got our usual topics and projects. So you ready to dig in?
Yeah, for sure. It's slowed down a bit, but it hasn't completely withered out.
Yeah.
It's been a weird year news-wise, not following the usual patterns. Maybe people are delaying their summer vacations or something.
Yeah.
First off, release news, Python 3.13.6 came out, which is mostly bug fixes, including some security fixes in the HTML parser. So if you're using that, you should go upgrade. Next, 2 bits of Django news. First, Django 5.2.5 came out, which has a few small fixes, including some crashes. And one I haven't heard from in a while, there's a new version of Django REST Framework, version 3.16.1, which also has a few bug fixes and a whole bunch of new translations. So if you want to read the docs in Korean, you can now. In more third-party news, Narwhals, the data frame compatibility layer library, released version 2.0, which includes 3 new methods for creating a data frame from NumPy data, from Apache Arrow data, and from a Python dict. The other release was mypy 1.17, the original, I think, Python type checker.
Yeah, one of them at least.
Yeah, someone's going to yell at me. There'll be something that predates it and I'll be wrong. That's fine.
Yeah.
And it includes an optional ability to validate that a match case statement exhaustively uses all possible conditions. So that's kind of interesting. There were 2 PEPs added. The first, 798, is titled Unpacking in Comprehensions, which proposes an extension to the tuple unpacking mechanism so it can be used in list, set, and dictionary comprehensions, as well as generator expressions. This can be handy to shortcut merging some kinds of iterables together and kind of naturally follows on tuple unpacking available elsewhere in the language. So I suspect this one's going to go through without any challenge. PEP 799 is titled A Dedicated Profiling Package for Organizing Python Profiling Tools. I think they should put profiling at least once more in the title.
A profile about dedicated profilers.
There are currently 2 tracing profilers that ship with Python. The first is called Profile, and the other is a C profile. Profile is a pure Python implementation, and it's mostly there for educational purposes, and its performance capabilities are, shall we say, limited. The second, as its name implies, is implemented in C and is more useful, but it only works on the main thread, which makes it sort of limited when it comes to the new free-threaded Python stuff that's coming out. So both of these are tracing profilers. Tracing profiler is one that instruments every function call, which adds a lot of overhead. Python 3.15 is going to introduce a sampling profiler, which does statistical analysis instead, meaning it doesn't need the full instrumentation. In theory, these should be lighter weight. This PEP proposes reorganizing where all of these things live, creating a new module named Profiling with all of the tools sort of living underneath it. So it's just a reorg kind of thing.
Yeah.
It also proposes deprecating the original Python-only based profile as it's more or less obsolete.
Yeah, I've had a lot of conversations about profiling over the years. And yeah, sampling is definitely the newer, more interesting way of doing things. And like you said, the earliest ones kind of, you couldn't really judge sometimes because it might actually add a lot of load to what was happening, which is kind of an awkward situation.
I haven't played with them myself, but my understanding with the sampling profilers is in some cases they're light enough you can just leave them on in production so that you can kind of use them as monitors as well. So I've only ever used the original sort of tracing kind when I'm bug hunting, right? It's like, why is this taking so long? But
right. Yeah.
It's an interesting approach. And then the next bit of news is about an email phishing attack pretending to be from the PyPI folks. The email came from pypj.org, which doesn't sound connected, but when you look at the letters, they're close. And it asked the user to log into the site pretending to be PyPI and then would steal your credentials. The security folks at PyPI were all over this, and already at the time of this recording, they've got the source domain taken down. They know of 4 people who succumbed to the ploy, but the results have already been cleaned up. They've redone credentials and mucked with the keys that were involved with it. So for details on what the attackers did, you can see the show notes. There's both a blog post and a follow-up incident report. Short version, ladies and gentlemen, don't click on links in email.
It has been the worst month. I mean, it's always awkward to say that in today's world, but as far as like attacks and malware and phishing and all that sort of stuff, it's like, oh my God, be careful out there, everybody, and make sure you tell your loved ones.
I think it's particularly with PyPI, there seems to have been a bit of an uptick, and I suspect some of that's just Python's popularity. This is what happens, right? Like if no one knows your website's there, no one's going to attack it.
The bigger target.
Right? So, yeah. And then my final bit of news is some shameless self-promotion. My book, Django in Action, has been converted to live audio format. So if you'd rather listen than read, you can check that out. Use code LADjango40 to get 40% off. Note that the 40 is 40 about the discount, not 40. The book does cover Django 5. And I believe you've got a bit of promo to do for a conference as well, yes?
I wanted to mention something. I had Aubrey Van Brederode on a little while ago. We were talking about using assistive technology and how that kind of relates to learning Python. Aubrey is someone who's lost their vision, and they are involved in hosting PyCon NL, the Netherlands. They reached out basically wanting me to make sure that people knew that they've increased their deadline for proposals. That deadline was increased to Sunday, August 17th at midnight. This comes out on August 15th. So if you get this in the morning, or maybe you send it in over the weekend, maybe you'll be under the wire for their call for papers. I'll include a link in the show notes and you can check it out there. It'll also be in PyCoders the week before. So if you see it reposted there, hopefully you caught it in time if you're interested in submitting a paper. All right. Well, I think that takes us into our topics this week. And I know that this is one of my touchstone topics, but I feel like I haven't talked about audio, music, or MIDI, or even electronics in a while. So this is a piece by Jake Edge from LWNnet. And Jake went to PyCon this year in Pittsburgh. And now I'm kind of jealous, partly because I would have really enjoyed this talk and probably had a bunch of questions for Peter Sobat, who he's a machine learning engineer. He works in the audio intelligence lab at Spotify. And the talk that he gives is about handling audio in Python and then subtitle using pedalboard, which is one of the libraries he works on there. And I think this library's come up before. I had Bartaj on, another Real Python core member here, to talk about this guitar synthesizer tutorial that he created, a very elaborate thing. And I think he was using it because one of the things that is a little hard to do, and as far as working with audio and Python, the built-in wave library is not fantastic. It's very, very low level, and you have to kind of do a lot of building and so forth. So to have a higher level library that can kind of do that stuff helps a lot. And I think that's why he chose to use it for that particular one. There is a YouTube video for this talk, and I suggest you check it out. I know it's sometimes nice to just read through a summary of it, but there's actually a lot more detail inside of it and a really well done set of slides and animations and so forth, kind of giving an idea of what's going on it. I don't want to spend a lot of time in this first section because it's really about how sound gets converted. I'll do my best short version of that if I can. This is my background. You probably can tell a little bit. I've probably mentioned it 1,000 times that I used to teach this stuff. So sound waves are pressure moving in air, sort of push and pull, and the microphone or other audio pickup device that is used converts the moving waves into an electrical signal. The unique thing is that it's not a scale that it would be measured like a graph starting from zero silence and then moving upward only. It actually is a push and pull. And so there are positive values and negative values, and actually the center line is actually silence. And so that's measuring the amplitude or the volume, if you will, of the signal. You can think of it as a float, which is common in this situation, and +1 being the pressure moving upward, and then -1 being the maximum level down. And so that would be recorded as a value inside there. The second part of that whole thing is that you need to continually measure that as it is a wave that's moving through. And that's done through sampling and basically taking these points along there. And the number of samples that you take in this process will determine what frequencies can be recorded. These get turned into a graph, a waveform. A common value that's used out there is to sample at 44,100 times a second, or 44.1 kilohertz, which is what a CD uses. Remember those, kids? And that is near the top frequencies of what humans can perceive. All right, rabbit hole, can't help myself, but does bug the crap out of me. How many people in our industry think that anything higher is useless and would never be perceived? Number one, those frequencies are there. They are created by instruments, and they are bouncing around in acoustic spaces and can be captured with higher sampling rates. Number two, you can sense harmonics even if they're at a lower intensity or a lower amplitude than the fundamentals, but some people sense them better than others. In fact, a lot of animals can have much more range of hearing, and so it makes sense that human beings have various ranges of hearing. And the only thing I want to say that's on top of that is that it's completely unnatural to completely cut them off like a cliff and not be able to even capture any frequencies above 20 kilohertz. So that is what I'm saying. Have I invested in an analog system that has that kind of response curve that's more gently sloping off as those higher frequency? No, I don't want to have a crazy elaborate vinyl system right now, but there's still time. Just make sure you don't send it down Bluetooth to listen to it. Anyway. Tangent done. Where were we? He provides a demo that attendees could play along with, which I thought was really kind of fun. He challenged the people in the audience to make noise during his presentation using it, and he created a demo with a little QR code that people could log into. So it'd be in the browser using PyDide and WebAssembly. Again, fun stuff here. I'm definitely going to be playing with that later. So the part I'm skipping is the whole idea of frequencies being captured and turning into numbers and identifying the notes in this case. Again, he mentions there's a built-in library that's been in Python, the wave module, but it's very low level, requires a lot of work to work with. And so pedalboard works as a great alternative to that. First examples that he uses in this are recorded audio files, and it handles pretty much any format you can think of that's popular today, WAV, MP3s, OGG, or those other kinds of formats that are a little bit more compressed or even less compressed, like FLAC. With it, you create a context manager. You do a from pedalboard.io import audio file, and then you can do a with statement and have a file handle on it. And then from there, you can do it kind of looks a little bit like reading a text file in some ways, that you can do like almost like a read lines type of thing to read those individual samples. In this case, when they read out, it's creating a NumPy n-dimensional array or ND array, 2 rows, left and right in this particular case, and then the individual sample amplitude levels as it's going through. He shows the Python code for all this, which is really kind of fun, slicing or picking out like the first 100 samples or maybe the first 10 seconds based upon the sampling rate and the last 10 seconds, and using some standard techniques that you'd learn in Python. He shows some basic manipulations. He does kind of a fun one with like echoing the sound. So in this case, you're able to create a copy of the wave at a quieter level, lowering the amplitude, if you will, and then delaying its time somewhat to create an echo effect, and then shows what's involved in doing that. And then he shows like, well, how could you do something, more elaborate? Like, let's take this clean guitar sound, and then using NumPy's version of tan H, or the hyperbolic tangent, he creates a distorted guitar sound, which is really kind of a cool demonstration. And this is really where the name pedalboard comes into play. As the name implies, the library has a lot of these audio processing functions and tools already within it. If you're not a guitarist, I would think most people are aware of the idea that guitarists usually have little boxes in front of them that go between the guitar and the amplifier to affect or change the signal. And often they're gathered into like a board to kind of control them all and have like a power supply and so forth. Sometimes they're referred to as stomp boxes. I'm a fan, you might think. I was actually known as the pedal guy in the band I was in, the other guitar player who wanted to be known as the purist guitar and amp only guy. So it was nice, actually mixed and blended the sound really well. So anyway, the library has a big collection of these, and you can use them in Python, as was mentioned. There's also a really cool thing that I wasn't aware about the library, and maybe this has been added since I learned about the library a while ago, but the ability to use plugins that have been created for other audio platforms like Logic or GarageBand, Cubase, Audacity, Ableton, whatever. There's a standard way to write the code for these things called VST, or Virtual Studio Technology, and Apple has its own called the Audio Unit format. Well, this platform can actually use those plugins, which I think is really cool. In fact, it'll actually pop up the GUI for it and allow you access to, if you will, the knobs and sliders through parameters inside of it. So it's something, again, I need to play with a little bit more. The pedalboard library also can do other kind of audio types of heavy lifting functions that you might be interested in, like resampling, converting sample rates, or changing file formats. Okay, I want to take an MP3 and expand it out into a wave, or I want to do the reverse, and so forth. I really like how Jake summarized this talk. It's a nice quick read if you're interested. But again, as a YouTube video, the talk is one of the better ones I've seen recently. He's really organized himself, and it's presented very well. I remember seeing him briefly give a lightning talk about pedalboard at PyCon in Salt Lake City. I'm excited to see the library is continuing to grow. He has another library he's worked on at Spotify that's called Basic Pitch, which I think I mentioned several years ago, but it turns audio data into MIDI. And I've actually been thinking about a project lately, the technology to separate a song into its individual instrument parts as actual audio files has become like an extra feature they just added to like Logic and other programs lately, which is pretty amazing. So you can take like a completely mixed song and say, oh, I just want the vocals or the bass or the guitar. So I think taking that and then pushing into something like Basic Pitch then would give you a much cleaner performant version of, okay, this is the bass line and this is the drums and so forth. So I'm excited to try that out. So thanks again, Jake, and thanks, Peter. What do you got?
My first article is by Paul Butler, and it's called Smuggling Arbitrary Data Through an Emoji. This isn't Python specific. In fact, the sample code in the article is Rust, but it's kind of neat, and I thought I'd share it. In the old days, you had ASCII, which had very little else in it besides the Western Latin alphabet. And it turns out there are more character sets than that on the planet, though, so along came Unicode. In ASCII, a single byte represents a character. In Unicode, you get what they call code points, and there can be one or more of them. The first few code points are the same as ASCII, which makes Unicode backwardly compatible. And more complex things, like, say, a flag or an emoji, are made up of several of these code points in a row. Then there are even more complex things, code points that don't print anything. These are called variation selectors, and they get used to modify the presentation of the preceding code points. So, for example, code point 2764 is a little heart character printed in black, but if you follow it with the variation selector 16, you get the red-colored heart emoji. These get used in more than just emojis, though. For example, they are sometimes used with Japanese text, kanji, to give variations of a character glyph. As glyph variations might get added in the future, current Unicode handling is supposed to leave any variation selectors intact, even if it doesn't know what to do with them. And you're probably getting the idea why the title of the article has the word smuggling in it. Because computer geeks are, well, consistent, if nothing else, there are 256 variation selectors, which means you can fully represent a byte through the use of variation selectors. Now, since computer geeks aren't always consistent, the selectors aren't zero indexed, they're named 1 through 256, but, well, what are you going to do? Maybe the spec creators were COBOL programmers. Anyhow, you combine all of this information with the fact that the Unicode spec is unclear as to what should be done with a sequence of variation selectors, except for the fact that you're supposed to leave them intact, and you have arbitrary, unprintable sequences within the illusion of a single character. So Paul's article shows you a little sample code that hides 5 bytes of data within the smiley face emoji, as well as how to decode the same if you received it. So if you look at it on the screen, it just looks like the smiley face emoji. But if you put it into the right tools, you'll notice that there's actually more than just the bytes for the emoji there. As I mentioned, this sample code is in Rust, but each function really is only a couple lines, and converting it to Python would be easy enough. It's fairly self-evident. When I was a little kid, you could buy a pair of markers, one which allowed you to write in invisible ink and the other that you used as a highlighter to reveal the hidden content. This was a little safer than the lemon juice and open flame trick, but the same idea. Well, now you know how you can do the same thing with your emojis.
I had a similar kit.
I think, it was a time and place thing. Yeah,
totally.
Yeah.
All right, so my next one is titled Don't Call Dunder Methods. It's by Trey Hunter on his Python Morsels site. I like it. It's a nice short piece. It has many links to much deeper dives on all the different items that are covered. We talk about these methods on classes often and refer to them by several names, but the method names have these 2 underscores before and after the name, double underscore, hence Dunder. The official name I learned after having a long talk with Brett Cannon about them is that they're actually called special methods within Python. I prefer that name over what was the common name at the time that I was hearing when I started Python, which was magic methods, because again, there is no magic there, I guess. But for some people, any amount of programming is magic, especially if you're hiding code inside of emojis. Anyway, TLDR, it's good to define Dunder methods on your classes, but you shouldn't call them directly as methods. Let Python do that. So now I'll go for the longer version here. Dunder methods allow you to add more functionality to your classes in a way that is specified within the constraints of the Python language. So they're like handles these things that are built into the language as far as like common techniques of things that you may want to add to a class. We can start with a really simple example, like often you want to inspect an object. Well, there might be a couple different ways to do that. One as a programmer or developer, and another maybe as an end user. And so there's a couple ways that can happen. So there's a Dunder str for representing that stuff, or the Dunder repr, which is actually what would be used to recreate that actual object if you wanted. I'm not going to go into the details there, but they're common ones that are there. So if you were to try to print out the object using the print function, you would normally be determined by what the string is versus the repr one. Similarly, what would happen if you initialize a new object from a class? You have a Dunder init. What should happen when someone uses a comparator operator with your particular thing? It may be pretty straightforward when you're talking about a number, but what if it isn't a number or something number adjacent, like a date? So there's a Dunder EQ, and you can create the code of like, well, how should the equality be compared there, along with EQ for equals. Again, normally would be called with comparing the two things with the operator equals, or maybe you're doing less than or less than equals and so forth. There's all of these are things that you can define in there. Context managers is something else we recently spoke about, where you can have an object that can be used within a with block, and it'll sandwich code between an entrance action and an exit action. I just talked about sort of the file handling idea, in this case of pedalboard, how it would handle the audio file dealt with. We often talk about it as far as like handling files, opening the file, and then always remembering to close it. Having this with statement allows you to do that inside that context manager. But here you actually create a Dunder enter and a Dunder exit if you're building your own context manager. Again, links to much more deeper stuff. But should you call Dunder enter? Should you call Dunder exit directly? Similarly, should you call Dunder len? Well, no, there's actually a len function that most people who are going to use your objects would normally think of Python as using. Similar, there's an str function for what the string should be used for, or just using the normal comparison operators. So he wraps up with this. I recommend that Python programmers avoid calling Dunder methods directly because there's not always a one-to-one relationship between high-level operations and individual Dunder methods. Dunder method calls signal that something low-level is happening. So you're doing, something very, very specific. A lot of these things that have underscores generally in Python are intended for the programmer to be using and not usually the end user to be doing this sort of stuff. As far as the library, there's like the idea of private things that are locked away in other languages. In Python, we don't have those things. And so we're using naming mechanisms to do a lot of that stuff. So there's usually a higher level way to do the same thing and it will look friendlier. So I like the piece. It's nice and short. Again, solid advice. Thanks, Trey.
So did he talk about why he has someone else given advice that you should, or has he run into it with his students? Like it seemed like a weird concept to me. Like he's explaining the stuff, so the content is fine, but it's like, are people doing this? I haven't seen anybody saying it's happening. That's why I wondered why he's phrasing it that. Did he talk about that he's seeing it with his students or something?
I think it's something that happens when somebody's learning the language.
Okay. Yeah. So, okay.
That they're seeing this used.
It's a function like anything else, so I can use it. Yeah. Okay.
They might be doing that extra step of starting to regularly use it in their code, but they're already the tools in the language to do that. And so it's sort of like an advice piece for people that have stepped too far. Who knows with LLMs also,
yeah, okay.
where they're grabbing things and using them inside there. So there might be something that's happening interesting there.
Yeah, true. Okay.
It's always one of those things that I always kind of wondered about when I was looking at, code initially in Python. And this was another one. I mean, the @ symbol for decorators, the type annotations that didn't seem to do anything. Lots of these little things that were like kind of weird, and Dunder methods were definitely one of those where I'm like,
right,
this is really interesting. And then how do I actually use them, and what, kind of how they're partnered up. So I don't know, it's kind of interesting advice, but I agree that like somebody who's an experienced programmer to be like, that seems odd that would be a common situation that people are doing this.
Yeah, no, I just wasn't sure where the question came from, but and coming from other languages that have things like protected and private methods, this was sort of obvious to me. Like it was a straight map.
Oh, this is how they do it?
Yeah, it was just, okay, Python doesn't have that. To compensate for not having that, they have this instead. So it never crossed my mind that like the whole point of private methods is don't call them. You're not allowed to call them. So when somebody says, oh, by the way, this is kind of Python's private, and I'm like, all right, fine, get it. Right. So I guess if you're not coming from that background. Yeah, the LLM's probably a good point, though. I suspect that's probably what's going on.
Potentially,
that's what's going on.
New ways to learn, yeah.
Yeah, okay.
It's time to shine a spotlight on another Real Python video course. And it's related to one of our topics this week. Python has a few important naming conventions that are based on using either a single or double underscore characters. These conventions allow you to differentiate between public and non-public names and APIs, write safe classes for subclassing purposes, and avoid name clashes and more. And the course is titled Single and Double Underscore Naming Conventions in Python. It's based on a real Python article by Leidana Esposo Ramos, and in the video course, instructor Stephen Loyens takes you through Python naming conventions that rely on using underscores, how to differentiate public and non-public names by using a single leading underscore, using double leading underscores to leverage name mangling in Python classes, exploring other common uses of underscores in Python names. I think this course is a good investment of your time, and learning how to follow and respect these conventions will allow you to write code that looks Pythonic and consistent in the eyes of other Python developers. Real Python video courses are broken into easily consumable sections, and where needed, include code examples for the techniques shown. All lessons have a transcript, including closed captions. Check out the video course. You can find a link in the show notes, or you can find it using the enhanced search tool on realpython.com. So what do you got next here?
My next article is called Inheritance Over Composition Sometimes, and it's by Adrian of the interestingly named site Death and Gravity. Adrian also goes by Lemon24. He's the maintainer of an RSS reader library for Python as well. This article is a follow-up to a previous one, but sort of a tangent, and you don't really need the previous one to read this one. They're sort of different topics. The previous article talked about writing a concurrent futures mechanism in Python, and one bit of feedback he got on the article was, I'll just read the quote, "Your code is too complex due to subclassing and many layers of delegation. Could this solution be implemented using only functions? I feel the classes would be hell to debug." So to help his readers understand why he made the choices that he did, this article implements the exact same code from the previous article 3 different times using 3 different approaches. The first is inheritance, which is how he got the original. The second is composition, and the third is through functions only. So let me give you a little bit of background first so you can understand what the approach is and what the code is. So many of the concurrency libraries in Python use an executor pattern. That's a base class which you use to define how many concurrent things you're going to have, and it's responsible for managing the concurrent code to its completion. So the original article created a drop-in replacement for the concurrent futures module, which defines submit and shutdown methods to manage the work, and a map method for mapping workers to threads or processes. So this is all about managing how many things are happening at the same time and how you express that in code. So his new version of this, the first implementation presented, which again is from the original article, uses inheritance. So it inherits from the original process pool executor, and it overrides the submit and shutdown methods, and then uses the concurrent futures module inside of it instead. The second implementation uses composition. So composition is the idea of creating an object that contains a reference to another object. So rather than an inheritance being is-a, this is the has-a thing. So instead of inheriting from process pool executor, the class creates a private instance of it, then manages it in the methods. This case still needs submit and shutdown in order to follow the protocol designed in the original requirements. And it ends up looking an awful lot like the original one, except there's a few extra lines for these private instances inside. And then the third implementation is a little further away. It uses pure functions. In this case, instead of there being a class, there are separate functions for initialization, submit, and shutdown. Once more, the heart of each of these functions isn't drastically different from the corresponding methods, but now they're self-contained. And like with composition, these functions need an instance of the process pool executor that they wrap, but in this case, it's got to be somewhere that's passed between the functions, and the approach Adrian took was to use a global variable. So the first 2/3 of the article outlines all these pieces and sort of the whys. The most interesting part of the article is the last third, which is where he compares the 3 approaches. It even includes a summary table with some pros and cons for each. The pros for inheritance were that it uses the least amount of code. It's more dependent on the underlying library, which is actually a good thing because that's vetted and debugged by somebody else. And the main con is the assumption that the thing you're inheriting from properly uses the API they've defined. So if they're touching private things inside of it, you overriding it might cause things to break. So if they've got sneaky private methods that they rely on, you might not actually be able to do the same thing. Of course, you'd figure that out as soon as you tried the code, though. So it really is only a con during writing the code. Once you've got it going, if it works, it works. The main pro of the composition approach is flexibility when it comes to naming. So with inheritance, you're sort of stuck with the names of things from the parent and the approach that they use. With composition, because you're putting it inside of it, you can do whatever you want with it. This isn't a terribly strong point, but if you're picky about the names, it allows you that flexibility. The cons with composition are the fact that you end up with more copied code, and if the API breaks, you might not realize it. So often the base classes, and in fact in this case, the inheritance have dummy methods that raise not implemented errors. So let's say you misspelled submit. Well, when you use inheritance, you'd get an exception when the code runs because the base method would get called instead of your method. Well, with the composition approach, there's no base method there that you're touching, so this wouldn't get detected that way. It would be, so you're pushing it off to later debugging, finding it during your debugging process. And then Adrian has very strong feelings about the third function-only approach. In the pros column, he just puts a question mark. In the cons column, it's a rather long list. He notes that this was even more copied code. It has the same naming problems as composition. And because of the need of a global variable, you only have one instance at a time, and some of the state is hidden by necessity. So the article goes on in further detail. One common bit of advice, which is sort of one of the drivers behind this article, is that you should favor composition over inheritance, as it generally allows for looser coupling. But the word favor is key there. It doesn't mean always. And in fact, this example is a perfect reason why you should be using inheritance. So Adrian breaks the analysis down into a series of topics: forward compatibility, global state, complexity, and then debugging. So if you're looking to learn more about how to structure your code and why you might take one approach over another, this article does a great job of comparing and contrasting these three design decisions. This is something I find doesn't tend to get taught. Most programming's teaching is about, I need to use these lines, then I call those lines, right? It's very syntactical.
Yeah.
The design stuff is something you tend to learn having read other people's code, and more often by doing it yourself and then figuring out that after having to maintain your own code, that was a horrible way to do it. I've come up with a better way, right? So practice does it. So I love these kinds of articles because a lot of these things aren't self-evident. And to the point here about, favoring composition over inheritance, that's good advice, and it's probably useful advice 90% of the time. But if your case is that last 10%, then you're hurting yourself, right? So this kind of info I find is really, really helpful.
It has so much more of the why than the huge collections of OOP stuff that's out there.
Yeah.
If you're learning OOP, you're learning object-oriented design, you learn what inheritance is, you learn what composition is, and then the problem is that they've done it through explaining animals or cars or vehicles or some kind of thing. And it's like, this is actual code that does something, and there's something going on here. And you actually get to see this, like, okay, well, here's where collisions are going to happen. Here's where renaming is going to be a problem. Yeah. And it's like gold, it's like having this kind of stuff. So more of this, please,
Yeah. There was I don't want to say argument. They were polite. There was a conversation on Blue Sky last week between Bytecode, whose articles we talk about all the time, and a couple other people about exactly that, because someone was basically claiming, that animal composition example is always damaging because the user, you got to show real world, because otherwise, and Bytecode's point was, I get what you're saying, but you got to start with a simple enough example. Otherwise, you're never going to learn those things, right? And
I don't know where the happy medium is. Like, it's nice
hard
to see something.
This is very, very hard.
This is even more advanced because it's like dealing with, asynchronous kind of ideas also. And
that's where that composition advice comes from, is because most often, because really inheritance is trying to express this is a concept. If you are using inheritance, then you're sometimes forcing things to be another thing when it isn't actually natural, whereas composition allows a much looser piece there.
Right.
So yeah, it's this is hard stuff, and I think it's worse in Python because this is so important to other programming languages.
Yes.
That importance leaks over into Python, and so we've had other articles where it's like maybe you just shouldn't use a class at all, and that's a choice in Python, right?
Right. Just do functions.
Yeah. A couple episodes back, we were talking about the design patterns. We're posting something to PyCoders this week that is actually the same thing. It's basically, should you be using a class? So yeah, this kind of decision making, just because the language can doesn't mean you always should. Yeah.
Yeah. I mean, the general idea of objects and so forth is the idea of this sort of portability, repeatability of code, and these structures that you can kind of keep to reuse. And, a function definitely is that type of thing. So it depends, like in other languages, you were forced to do that, like literally for the hello world and things like that.
Yeah.
So great piece. It was nice to see. Well, I think that takes us into projects. My project is kind of a fun tool if you're dealing with HTML today. A common thing is to want to be able to pull information out of HTML and potentially a format that you may want it in is a Markdown. So it's literally called HTML-to-Markdown. The project is by Naaman Hirschfeld, and they go by Goldsire. Their title basically says, this is a fully typed Python library for converting HTML to Markdown. It's been rewritten from a tool called Markdownify. They're very, very key on adding that. It's got type safety and support for Python 3.9 and higher. It also can get a bunch of performance boosting from another tool for parsing XML and HTML called LXML. And the tool also works with Beautiful Soup. So you can actually pass like a pre-configured Beautiful Soup instance for kind of more control over the HTML parsing. So it's something that if you're already maybe pulling information off websites and stuff like that, it has custom converters. You can provide your own conversion functions for specific HTML tags. It has enhanced table support. The doc includes a nice table for configuration options, showing the option, its type, the default values and descriptors. It's a well done README, examples of how to use it as a CLI and resources if you want to contribute to the project. Good code examples throughout. So again, if you're working in the web scraping space and need a tool and want to be able to turn it into a common format today, which is Markdown, this is a nice tool.
It's nice that it supports both Beautiful Soup and LXML, because LXML tends to be a little more strict and Beautiful Soup is a little more forgiving. And a lot of HTML that's out there is broken and against the standard. It's kind of amazing what browsers do.
There's literally a history of it.
It's like the browser's just like, yeah, it's fine. That text is not supposed to be there. I'll show it anyways, and it works. So being able to have both of those options, depending on how dirty the HTML you're parsing is helpful.
Yeah, cool. So what do you got? It seemed like you had a project and an add-on here.
I've got two quick things this week. The first one is quick because it's simple and useful, and the second one is quick because it's complicated enough that I'm just not going to say that much about it.
Okay.
So the simple and useful one first. The library is called curlify, and it's by GitHub user OFW. In case you haven't used it before, curl is a great command line tool for fetching data. It supports HTTP, FTP, IMAP, SMTP, Telnet, all sorts more. I use it all the time when trying to quickly test a web server from the command line, and it's particularly helpful when you're debugging a web-based API. So the curlify library is a helper that translates a Python requests call into the curl equivalent. So this can be useful if you're debugging and you're not sure whether the failure is due to your code or due to like a problem on the network. So by being able to switch to curl, you're outside of your code, so you can validate whether or not what is the network doing, and then you can figure out whether or not there's a difference between that and your code.
Isolate some stuff there. That's good.
Yeah. The library is essentially a one-liner. So let's say you called request.get on a site. To see the curl equivalent, you just call curlify's toCurl method on the response object. The result is a string with all the command line arguments curl needs to make the exact same request. And this goes beyond just the, hey, here's the URL. It also includes the various header values that request is doing for you, that might have been default that you weren't even aware that they were there. So if those are the things causing your problem, you'll actually also see, those show up as you go along. So it's a neat little tool. I'll be adding it to my toolbox for the next time I'm debugging an API.
Yeah, you're already a big curl fan.
Yes. Yeah. It's for those who've done some of the courses that I've done with networking stuff in it, you'll see I use it all the time. So the second library is kind of meaty and complex. It's called Transfunctions, and it's by GitHub user Pompenchik. We've featured stuff from him before in episodes 200 and 207. A lot of libraries that support asynchronous methods need to also support synchronous ones, as you can't easily call one from the other. You can, but it's problematic. So the transfunctions library gets around this by providing a wrapper decorator that returns a code object which can be invoked in sync, async, or generator mode. So it does all this through the magic of AST code generation on the fly. So there's some deep magic going on here. But if you're writing code that needs to support both sync and async, this library might actually help you out. The README is very detailed and has way too much to cover here. But I did want to give the library a little shout out for those who might find it useful. So if you're playing in the both async and sync world at the same time, maybe this will help you out.
Nice. All right. Well, thanks, Christopher, for bringing all these articles and projects this week again.
Always happy to be here.
Talk to you soon. I want to thank Christopher Trudeau for coming on the show again. And I want to thank you for listening to the Real Python podcast. Make sure that you click that follow button in your podcast player. And if you see a subscribe button somewhere, remember that the Real Python podcast is free. If you like the show, please leave us a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Paley, and I look forward to talking to you soon.